All right. Well, happy Monday again. Uh, Hopefully, you had a good Thanksgiving break and either got some work done or did no work at all. Whatever you wanted to do for Thanksgiving. Had some tofu turkey, right? Everyone, you enjoy your tofu turkey? Is it just me? Okay, that's all right. I'll be the weird one. Uh, so, our last chapter of material, super exciting. Here we have almost made it through everything now, and when we get to chapter 9, we're not going to do all of the stuff here. So we're going to talk about it here, but we don't need to do all of it. So we go, because you'll come back to a lot of these topics in CIS 200, which I think you've all registered for now, right? Did the good time section fill up, or do you get stuck in like the really late evening one, where they only had a couple that were at decent times? Someone wanted to meet at 9:30 in the morning. If you like mornings, that's great. Good for you. I don't like mornings, so oh, so we're not going to do. Okay, so it fits with that. Yeah, it gets it out of the way, I suppose. So we won't do these last three labs because we don't need to do these linked list things. You'll get to that next semester. Um, so let me go on a configure. I think all the other labs we've done. Just pull things out here real quick, and I want to move to where do I want to put it? Additional labs pointers. There we go. All right, that should move those out of the way for you. Okay. And then, so the other chapters here I've marked as optional. If you want to look at them, great. I'm pretty sure it's been a year since I taught CIS 200. You'll get another Zybook for CIS 200, which is the same Zybook, which sucks. I'm sorry, but then they'll do the Zylabs maybe for just these ones, just the new stuff. So, um, if they don't have the Zylabs and they don't look at participation stuff, this one is available for a little while here, but not long. Um, you can get the book up until January 5th, and then you'll lose access to it because you've paid a fee to use the website, and it's not a real book you get to keep, but you can go in and print one chapter at a time. So, and you can just print it to a PDF, right? You don't actually have to print it to paper. You can just do a little PDF print. So when you're doing that, go ahead and print your chapters to PDFs. So you've got them for reference, just in case. I forgot to talk to Dr. Shen to see what they're doing for 200. But we used iBooks last year when I taught 200. But we didn't have the lab portion. So it was just the reference here. And then, of course, there's the expensive textbooks that you can buy if you like expensive textbooks, which no one ever buys because they're expensive. But the library usually has a couple that you could check out that he recommends. So, depending on your style, what you like, but go ahead and I would print these to PDFs. Uh, don't share them because your name's all over them, and then Zybooks gets cranky if your name on a PDF shows up somewhere else. They strongly discourage that. I don't think they ever sue students, but um, I don't know. Just don't, right? You can all go in and print it. Yeah, and then or even email your 200 prof if you know who's teaching it next semester and ask what if they're doing Xylabs or not. Um, Might be worthwhile. So trying to get you your money's worth out of paying for this if I can. Sorry. Um, and then remember the labs are required. They take a while. Right? We've been hopefully keeping up with them. I'm not going to check until the end of the semester because, like I said, it was a lot of work to do. I don't want to do it every week. So, and hopefully you're keeping up with it. If not, you're adults, you can set your own schedule, that sort of thing. So around 12:11 or so. So I'll probably run it a couple days before 12:11 and put a score in so you see what the score is. And then I'll run it again after we do our presentations to get everyone's last minute, whatever they wanted to get through for participation points. Um, and then Xylabs, right, makes up 10% of your overall score just for doing the things here in Xylabs. Right, our labs that we do every Monday make up another 10%. The projects make up 30%. The midterm was 10%. I think I've got all those in for you, right? I think I got all those in. And then the final project is 40%. Right? The final project's the bulk of it here. So that's what we're working through. I'll get your project scores in for you as well. You all scored yourselves, right? Doing the self-assessment for me with the rubric and drop that in your README. So I'll go through and pretty much everyone gets that score unless you just completely lied to me, right? If you said, "Hey, I did everything," and then you just didn't do it, that's you won't get. Does water just drip? There is. There's water dripping. That's not good in the computer lab. Okay. Um, I, I don't have a bucket. Um, right. It'll be fine. We can put a trash can there for now. Okay. That's ridiculous. A new $90 million building. Spending money? Yeah. Oh, sticky water drip. Nope. This is it'll be whatever room we're in. 2026? 2026? All right, I'll put in the ticket and let them know. It's all right. Building actual physical stuff is hard. Software is so much easier because you just hit run again and build again. It's really easy to do over. Um, all right. Yeah, so for scores, I'll get those in for you so you'll know where you're sitting with that. Um, hopefully, having the rubric and doing the self assessment made you feel better about it because you know how you're getting scored and you scored yourself. So, and if you missed one or two things, it's not the end of the world, right? It's okay. The idea with this is it's bigger practices, right, than the labs that you were working on more independently, and then they sort of all build up into this fun final project. Someone had asked me, I forget if it was this class, I'm giving both my intro classes the same project because Monopoly is fun, where you get Monopoly values, right? So like the rent amount for properties and things like that. You can just Google it. There's a website, Monopoly like, property values, I don't know, or something like that. And there was a list like this is the costs here, and then here's the rent. Oh, that's not even any of them is going to be fine here. Like it doesn't, if it's a different version, it'll be okay. So this will tell you. And remember, we're not doing the houses and hotels portion here. We should do the set though. We should. I don't think there's specific points in the rubric for doing the set. So if you don't have it, that's okay. Maybe add this as it would be nice as a stretch goal. So if you own all three of these light blue properties, you get the double the original rent because you own all three. That's how that one works. There's always double. Um, so if you don't, that's okay. If you do have it, that's cool. It's a quick check. Hey, do I have this, this, and this? Right. If you don't have this, if you don't own this one, and this one, then that's fine. You don't. Right. We're just going to look at the properties in the array list for a given location to see what the rent is. So that's okay. All right. And then we are coming up. We have more than 10 days left, right? If you haven't done a single commit yet, right? But we do need 10 days worth of commits, right? Incremental progress. And we get started. I have something that runs here. Great. Okay, I've got something that runs here. Great. I've got something that runs here. Great. If it doesn't entirely run and it crashes, that's perfectly fine, right? You don't not commit just because it's crashing. That's okay. But the idea is as you're writing your software, you don't want to wait until you're done with it to see if it works, right? You want to build a little bit and see if that little bit that you built works. Can I move around a board or something like that and tell you, hey, this is the space you're on, or put some names to things, or can I track one player? However you want to build it out, right? We can tackle it in little piece by little piece by little piece, adding things in as we go. That's how generally we build software because it's really hard to get from nothing to everything here. Uh, Now, some people might make jokes and say it's like building a plane while you're flying it. It's not that, right? It's not that complicated because we're just adding small features as we go. So there's a fun little video I can show you later about that. All right, so we're moving on to pointers, our last topic here. Um, so we're not going to do our linked list stuff. That's okay. We won't get to that. We'll look at some of these cool things here. You'll do copy constructors, copy assignment operators, this rule of three thing in 200. Um, this is lots of fun, but we'll take a look at memory leaks because that's the important thing. Because C++ lets you do lots of silly things here. Um, and weirdly, we don't get into any of the new stuff, which is kind of sad. There's new stuff that helps prevent these sort of things, and we don't use them because you got to do it the hard way or something. So sure, that's fine. So this is chapter 9, pointers. Now, no one really likes pointers here when you first learn them because they're a little bit confusing. and that's okay. So far, when we've had objects and classes, right? This idea we could build a class and we could make it do something. And then when we use that class, we have our reference to the class. Right? We did that a little bit here. I think we had our class. I don't know, what do we want to have? Like, how about chair? Oh, we had student, right? Class student. And it had a public section, it had a private section, right? And in the private section, we had maybe an int for, or maybe a double, right, for their score. This is kind of the important one here, right? And maybe a string for name, right? And then we wanted public methods, way to get at these private attributes. You don't generally want your attributes to be public. That's considered bad form. The proper way to build classes and use encapsulation and abstraction is to hide away all your details and give people public functions to use, right? And that way we can control things like when you set the score, you can't have a negative score and you can't have more than 100, right? We can put bounds around that. And because people have to use our public functions, it protects the integrity of our class to make sure we're within bounds. That's one of the big benefits here. So we'll have a void set score, takes a score, and then we'll say if my score is greater than 0 and my score is less than or equal to 100, maybe we'll take the score. We have this score equals the score. So this is actually a pointer. And that's why we use this silly little arrow notation. We'll see this arrow notation all over the place in just a minute. Okay, so we've been using a pointer. We just don't really talk about it. So that's okay. Otherwise, then we just don't do anything with score, or maybe we just say else score is 0 or something. That score is 0. Give you some sort of default, right? Greater than or equal to 0, I suppose, is fine. So that's our set score. And we'll have a double forget score, right? Just return score. Now, if we don't have two different things named score, we're okay, right? I can say score, and notice when I click on it, it highlights this score down here because it's the same value of score here. Our IDE is trying to help us here be useful. When I click on score here, I see the gray argument score, the parameter score, not the white class level attribute score. Okay, so just it's one of the things it does to try and be helpful for you. And then we'll have a void for set name, given a string for name. Now, I don't really care what your name is, right? It doesn't affect anything, so I don't need to do any sanity checking. So I'll just say name is name, and then we'll have a string for get name, and that just returns name, right? So we have sets and gets for these. That's about all we need right now. We could do more interesting things later. We could say, hey, given a score, I can get out a specific letter grade if I wanted, and all sorts of other fun stuff. But this is enough for now. So if I were to make students here, right, I'd say student is the type here, and we'd have Eric, and I could say Eric dot set name to Eric, and I can say Eric dot set score. I'm going to give myself 100 because, of course, I get to do that, right? Sure. So now I've got my name here, got my student. Now, if I want to do maybe make a function that prints out student details, right? Maybe we'll make a void function here for print details. This could take a student, right? We'll just call it student. And we could see out my student dot get name and an end line and a see out student dot get score. Oops, these ones, parentheses, some arrows and an end line. And maybe we want to like put in some details here, name and get name and score. I don't know, just make it look a little prettier, right? We could do that. So this way I don't need to have this same 2 lines of code everywhere. And imagine this could be bigger, right? We could be doing more interesting things or maybe have more details about student. But now I can just say I want to print details. I can give it Eric. Right? That's my student. And before we've looked at if I just pass Eric here, remember by default we pass things by value, not by reference. So I'm passing the value of Eric here, right? So if I wanted to, I could say student dot set score and say, I don't know, let's set it to 75, and then we'll print out the details. And then I'm going to grab these ones here. I'm going to do it again with Eric. Right? So I'm going to put a breakpoint in here so I can pause it and see what's happening. We'll run into debug mode. I'm going to pass Eric to my function here. Right? So we're about to step into my function. I can pass Eric into here. Okay, so I've got my student, I've got a name, and I've got a score, right, of 100 and Eric. I'm going to change my score to 75, print it out here, and now we come back, and now my Eric variable here, score is still 100, right? I called set score up above, but remember, because I passed this by value, I actually got a copy of Eric, right? I didn't give you the memory location and say, you can go work with this one. I didn't give you the reference to it. I passed it by value, right? And maybe that's what we want, maybe it's not what we want. So depending on what we're doing here and how big our objects are, if this was like a book and I had a bunch of chapters in it and they had a bunch of text and we had Moby Dick, that's like a pretty sizable book here. If I passed a copy of it, I now have it twice in memory. That's not very efficient, right? We don't want to have to do that, right? It takes up extra time, those sorts of problems here. So we could go about it and say, hey, I want a reference here to student, right? So give me a student reference. So tell me where it is in memory. Don't give me a copy of it. Just tell me where it is. Right? And I can go and use my functions here. So we step into now. I'll set my score to 75. And when we come back, my score is still 75 because it changed Eric's version. I didn't pass a copy of it. Right? I passed the reference to it. Is what we did here. So the changes I made to it stuck because I didn't have two of them. I didn't have a copy. I only had the one. I said, here's where it is. Okay. So able to work with it that way. And if we pass things by reference, and which is fun because you don't have to change your print details at all. Okay. Now, one of the things we saw, it didn't work very well for me here, but we saw in our diagnostic tools how much memory we were using here. My demo didn't go super well like I wanted it to. Yeah, it keeps pausing on me. Should give me more. It should tell me how much memory I'm using. I don't know why it's so cranky. Um, but all of these values here, when we create things, are going on the stack. So we've got two different kinds of memory here, and we talk about that a little bit. These memory regions here. You've got the stack and you've got the heap. So remember, the stack also tracks things. This is the call stack. So what function called what function, called what function, called what function, what the values were, what line we were on of each one. That's the call stack. Everything is saved in the stack. Eventually, you can run the stack out of space and you get a stack overflow error or exception that crashes your program. You might have heard of a website known as Stack Overflow. They named it after that, right? So that can crash your program. So the stack has limited amounts of memory. This is our automatic memory here, which is pretty cool. So computer takes care of it for us. Now, we've got a lot more memory available in this thing called the heap. The heap is the free store where we just go ask for more memory, more space, and the operating system will take care of that as long as it's got something available here. It's not bound like the stack is. Right? Eventually, the computer runs out of memory, but we can allocate things on the heap memory here by using a new keyword. Right? So the new keyword is what we're going to start using here. So when we're using pointers, right, the idea with a pointer is it points to a value in memory. It's a little weird here. So the idea with a pointer is it just tells you where something is in memory. It points to something in memory. So we've used this before, right? This is a pointer. It says this is where the object is in memory, right? Here's where it is in memory. Here's its attributes. Here's where it is in memory. Here's its attributes. So we've used the this pointer before. And we're going to start using our pointers to call functions. So if we have pointers, let's go to this one here. We can start using those same using the same notation with the arrow notation. So they're really silly looking here. So when you use a pointer, we have some new notation here. So this is their first example, like, hey, I want an integer for number, and we'll say it's 42, right? That's fine. And then if you want a pointer, you say it's an int star. So star is our keyword here to tell us it's a pointer. Here's a number pointer, right? Actually, let's copy them a little bit better here. So we got number pointer. So if I use the star, it tells C++ I want a pointer. So I have a new variable that points to somewhere else in memory. That's all it does for us here. So now I can go and assign some values here if I want. So I can say, hey, my number is 42. Now, the value stored by a pointer is a memory address because it has to point to somewhere in memory. It doesn't actually store an integer. It stores the memory address of an integer. Right? So pointers store memory addresses where their value is stored. So number pointer value is a memory address. So I can set number pointer, and I can say, hey, number pointer's value is the address of number, right? We'll set the value of number pointer to the address of number, right? And if I want to see out, here's my number. Number is, here's number, and then line. I can do that. And then I can also now use the number pointer here. So if I say number pointer, now if I just see out number pointer, am I going to get 42? No, because the value of number pointer is memory address, right? So let's take out my breakpoint here. We can run this. Pointers make your head hurt. It's okay. So the value of number pointer is 5A, 8B, 9E, F6, F4. That's the memory address in hex, hexadecimal notation, base 16, because why not? Uh, where 42 is stored in memory on my computer. Sure, that's the memory address. Okay. If I want the value of number pointer, what number pointer points at is pointing at. Now we do some silly things. So I can put in, usually I like parentheses here. I say I want to dereference my pointer. So it's telling C++ this is a pointer when I declare the type here. If I want to use it here, you don't have to use the parentheses. I just like it because it calls it out a little bit more specifically. Either way is okay here. This is dereferencing. So the star next to the variable name says get the value. Right? What is it pointing at? So now we run this one. We'll see it's pointing at 42. Right? We got number, we got number pointer. Right? This is what it's pointing at. And it's a different memory location every time the program runs because it's whatever Windows gives C++ here. Right? C++ says, hey, I need a place to store an int. Windows says, here you go. Here's a spot. Right? You get a different spot every time. We don't care. Right? The level doesn't matter to us. Okay? So if I wanted to change the value of number, we could say, hey, number now is 777, and number pointer, the value stored by number pointer, is going to change, right? Because number pointer just points at what's stored where number is. When I change what's stored at number, we get that new value. Right? So now I really have two things pointed to the same location in memory. I've got number, which points to where it is, and I've got a pointer pointing at number, wherever that's stored in memory. Not super useful yet. That's okay. We're just sort of practicing this notation here. We're dereferencing things. Okay. So there's values here, right, of our pointers, values, pointers. Let's see. When you make a pointer, it defaults to null. This null pointer, you can set it to nothing. It has no value. Um, it's usually pretty good. So if I just say what it's pointed at here, before we do anything with it, let's try this real quick. Uh-oh. Number pointer has never been initialized. It knows there's no value here. It was never given a value. So I can do it with number, and we get a garbage value. You try and make a pointer with no value, and we can't even compile now. Right? So generally, you'll start them off as a null pointer. This null PTR is a special keyword here that says you point to nothing, to null. And now when it runs, well, my value here is essentially 0. I can see the value of number pointer. It's not pointed at anything. It's really 0 here. But when I try and dereference it, I can't read that location. It says read access violation. You can't read from null. because C++ says there's nothing here to read that's an invalid location. You can't read this. It's no good here, right? Now, if we tried to say, hey, let's say let's assign it 777. Again, oh, an int can't be used to initialize an entity of type int star. We can't give it an integer value here, right? It's not an integer value. It's an actual memory address. So the things we can give it, right, are addresses, like the address of number here. So I'm just going to comment this out here. So we can't access where a pointer pointed to null is pointing. That sounds like gibberish here. You can't access where a pointer pointed to null is pointing. But if it's pointed to null, you can't go read it. You can't access it. There's nothing there to read. C++ will stop you, right? It'll just crash. Crash. Okay? But once we assign it a value, we're good to go. Now, the other interesting things we can do with pointers and integers are we can make what's known as dynamic arrays. So dynamic arrays take advantage of heap memory, not the stack memory. So I can say, hey, I want an integer pointer here. I want, this will be numbers. Let's say like 50. Now I have room for 50 numbers, right, in my array, just like we did arrays before, right? I could have, hey, I wanted an int array of size, I don't know, 50 here. This is, I don't know, stack array. Nope, this way, right? So this is my, I should call this the heap array. Here, so this is my heap array for 50 and my stack array. So when we use a pointer here, we're going to get allocated memory on the heap, not the stack. Oh, I'm missing a keyword here. Hang on. I'm doing it wrong. Where'd it go? I can never remember the syntax here. Let's see. There we go. We need the new keyword. That's what it is. Here's my new keyword. There. Okay. New. Okay. Equals new int 50. There we go. So the new keyword we need to use when we're using pointers to allocate memory. So this will give me a space for 50 integers, and this will give me a space for 50 integers. It's not very exciting, but we can start them off and we can access them the same way here. See, here's my stack array, all garbage values, and here's my heap array. Problem with using dynamic pointers, dynamic arrays, is you can't access them. Like, you can't see their values in debug mode, and I hate them. They irritate me a lot. Not a big fan here, because I like to be able to see values in debug mode, right? But, you can go use it again, right? For int, index is 0, index is less than 50, index plus plus. A heap array at index is, I don't know, we'll just do index times 2. Why not? Count by 2s here. We'll do the same for the stack array here, right? So we can go set some values here, and then let's do it here. So we'll assign it here for my heap array. So I can see the first value is 0, but I can't see anything other than that in debug mode, which is really sad, right? But as we go through our stack array, right, your stack array, you can go and expand and see all the values show up. Okay, so these are like sad for debugging, right? My memory, why is this not working? This is so sad. Usually this works really well for me. I wonder why. Maybe, is it waiting? Hang on, let's have an int for value. See in value. Is it going to show here? There, okay, now it's showing. I think something about pausing in debug mode made it sad. So now it's waiting. So I'm using 735 kilobytes of memory for my process right now. Not a whole lot here, right? If I go through now and make more of these, right? How about for int array is 0, array is less than, I don't know, let's do like 100,000 of these just for fun. We'll just make a bunch of these here, right? Now, every time I use the new keyword, it allocates more memory. And allocates more memory and allocates more memory and allocates more memory here. So when I give this a run, we're going to see my memory usage now. I'm at 31 megabytes of memory or so. It's a lot of memory, right? It's kind of a bummer because I've allocated 50 integers 100,000 times, right? So 100,000 times 50 times 4 bytes or so, it probably adds up to about 31 megabyte, I would guess. Okay, that's kind of a bummer. Now, if I were to do the same thing here, let's make a bunch of stack arrays and see how much memory we're using. Still 31 megabytes, right? Usually what we've done so far in the stack, when we're done using that variable, it can get garbage collected, it can get thrown away. We don't need to hold on to that memory anymore because it's automatic memory. It automatically frees itself up. When you use stuff on the heap, it does not go clean itself up until you tell C++, hey, I'm done with that memory. So when we make a heap array, and then we make another heap array, and we make another heap array, and we make another heap array, we never tell it we're done with it. C++ is still holding on to 100,000 arrays of 50 integers. It's still holding on to all that space. So there's another keyword we need to start using. That's the delete keyword. When we deallocate memory here, where is it? We can say delete to free up the memory allocated with that new operator. So I can delete the array here. So I can, after I'm done with it, I can say delete array of my heap array. This frees up the memory in the heap. So now when I run this, I'm not going to be using 31 megabytes anymore because I've freed up that space. Now I'm back to my 761 kilobytes here. So we've used it and then we delete it. We use it, we delete it. So delete doesn't actually delete it. It just says, hey, I'm done with it. And it can get freed back up and used by your operating system again for something else. So now once we start using this new keyword, we're able to shoot ourselves in the foot. That's what we call a memory leak. Right? This idea that memory leaks if your process keeps using more memory and 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 keeps using more memory because we never freed it up here. So some programs you might notice, like if you go to Task Manager, most of them are pretty good about not leaking nowadays here, right? You can see how much memory are being used by things. Um, some of them never go down. So my Edge is based on Chromium, so it's going to use up lots of memory as well, just like Chrome. Google Chrome takes up so much memory, and it likes to hold on to it here because it's garbage, but that's okay. Um, so if you have a process that never frees up memory that it allocates, it has a memory leak. Eventually something will crash because we'll run out of memory. So if we wanted to, we could make this even more here. Don't let's do this like 500 and we'll go up to a billion or so here. Let's see. I don't think it'll be super slow. I want it to like be slow. Let's just see out array. So see outing things makes it take a little while longer here, right? So we should be able to watch. Oh, hang on. I wanted to not, let me forget the delete here. We want to watch it kind of leak as we go. Okay, so it's going now. So you can see the process memory is climbing here. And climbing and climbing and climbing and climbing. Right? We did this one on purpose, but essentially some programs that run and like wait for input and those sorts of things that stay open and they don't just run to the end and close themselves. If they have a leak like this, eventually they'll crash, right? And that's no good. So slowly we can see, where's my memory? Visual Studio just keeps eating more and more and more memory. This is the chapter 9 pointers exe keeps eating more and more and more and more memory. I've got enough on my computer. I think we'll be okay for now here. Right, but you can see it climbing. This is kind of the fun exercise. You just watch it climb and watch it climb until you get bored of watching it. Right. So that's because the C out is super slow, right? In terms of how fast computers can do things, spitting something out on the console is really slow. Right? If we took out that C out, it'd be done like that because it can do those operations really fast. But spitting something out on the console is really slow. So it just sits here and waits for a while. All right, we're getting close to a gigabyte now, right? We're getting there. 776, 79. Looks like I'm trending lower than the whole process here. This is just the chapters 9 pointers exe. Yeah, because I'm not freeing it. We're trying to leak on purpose here, just as an exercise. Now, there are things called smart pointers, which when you're no longer using the smart pointer, C++ says you can free up the memory. It automatically deletes stuff for you. Generally, that's pretty helpful. Occasionally, if you do it wrong, though, you've deleted something that you meant to hang on to, and then you're really sad because it was deleted, and your program will crash when you try and use it later. So I think that's probably why you skip smart pointers for now. You can get back into those later. Yep. So we just keep on eating more memory. It's very exciting. We're not even at a million yet, right? Or no, this is 600,000 arrays. We didn't even hit a million arrays yet, right? Don't think it's going to crash on me. It'll take a while here. So if you wanted to, right, we could. I'm going to try and make it crash. Let's go 10x. So let's do 5,000 integers per array here. Let's see what kind of memory we're going to use up. See, it's going a lot faster now, right? 10x the speed. Let's see what it does. Should I go even faster? We should go even faster. I'm getting bored watching it already. Trying to see if I can crash my program. There we go. A gig, 2 gig, 3 gig, 4 gig of memory, 5 gig of memory, 6. Oh, something got cleaned up because it went back down. 6 gig. So it's something's keeping it from climbing forever here. I don't know what's happening behind the scenes, but it's not going to make it crash though. That's kind of exciting. So somehow it was managed. I don't know what was happening there, but I think my computer was trying to make sure it couldn't use up all the memory because it was about to run out. I'm going to be really sad. Windows has gotten a little bit better about that. It used to crash really easily because I'm an old person. So, all right. So that's pointers. That's allocating things with the new keyword, trying to avoid memory leaks. Now, this is just with arrays here and dynamic arrays. We can also use pointers with classes, and this is really where they start to shine and become very useful. Um, we'll get into that next semester more when we talk about inheritance, but I can make new instances of classes if I wanted that student class. So, hey, I want a student pointer. We'll call this one Jeb here, equals a new student. So when I use the pointer, I have to explicitly call this constructor. Did we talk about constructors? I don't think we did for classes yet, did we? Okay, so we'll get into constructors a little bit here. I don't think, yeah, it was in the Zybooks, if you got a chance to look at it here. So constructors are a special function that lets you create your object. So we can say, hey, instead of having to call all these set methods here, I can make a method, and constructors are special. Constructors don't have a return type. So it's just student here, and then you tell it what variables you want as arguments or none. Right? You notice we were able to make students without giving it any arguments for score and name. Right? So I could give it a no argument constructor if we wanted. This is known as a default or no argument constructor. That's fine. So what would be nice here is to say, hey, my score is 0 and my name is an empty string. Right? This keeps you from getting garbage values. Right? A constructor's job is to give values to the class attributes. Right? I don't want garbage values. So constructors' jobs are to give values to your attributes. What is a good default value? Great. You can also have more than one constructor. You can overload these things just like we could with functions, as long as their parameters are different. So I can have a student constructor that takes a string for name and a double for score. And I'll say this name equals the name. And then I already did a bunch of work with score and validating score. So I'm just going to say this dot set score given the score. Right? I want to use my set score function because I don't want to have the same code twice and feel bad about myself. So I can call set score. I think I actually can skip to this. Yeah. I can just call set score here. Say, hey, go ahead and set the score, please, using the same function. Okay. So now if I want to make a student, right, I can make a student with the no argument constructor, or I can make a student. Let's have VV here is a new student. VV, and we'll go 75. Right. Now, if you have a pointer, you don't say Jeb do the arrow. It shouldn't do the dot. I'm confused why it does the dot. Yeah. Oh, it's going to replace it anyway. Okay. So it's trying to be helpful here. If I try and get name, it replaces it for me. When you have pointers, you don't use the dot notation anymore. When you have pointers, everything is the arrow notation. just like we did the this arrow. So if I say jeb dot set name jeb, it's going to replace it with this arrow notation now. Pointers use instead of dot for functions. I don't know why, honestly. I have no idea why. That's just what you do. So jeb dot set score, right? Let's give jeb a 95 or so. So I could use my no argument or default constructor and then set values, or if I write a parameterized constructor, a constructor with parameters, I can just do it on one line. I bet you can guess which one I'm a fan of, because I'm lazy. The one-liner, right? This is so much easier, much less typing here to have a constructor, right? The other cool thing you can do here is once you have a constructor, you can now make values essentially read-only, right? If you are not allowed to change some kind of value, you can accept it in the constructor and then never give them a set function to change it. So for student, this one's not super exciting here. Maybe we have an int for, so like you can change your name, right? You can go and legally change your name here. But what if we had an attribute for ID, right? You all have an ID number, a student ID number. That will not change no matter what, right? You can go change your name, tell the registrar's office, hey, I changed my name, and they'll say, okay, sure, we changed your name. That's fine here, but you're not going to change your student ID. That one will be stuck. So changing your name doesn't wipe out your transcript. I think it'd be pretty sad if that happened, right? Probably you'd be pretty sad if that happened. I guess if you didn't do so well in your classes, right? So if you want this to be read only, you don't give them a public set function for it. You just give them a get ID function. Return ID. So if you need a way to set it, then you have to pass it to the constructor or set it in the constructor somehow. Maybe I just make these random, right? ID equals rand. What do you want? Like mod, probably 100,000. We could give it like 6-digit values, right? No. So we need 99999. That's 800,000. 900,000. I can't math right now. With the same Ticketmaster math, right? Plus 100,000, right? If we want 6-digit student ID numbers, we'll just take a random number, mod 900,000, add 100,000 to get 100,000 to 99999, right? So in my constructor, I can set it to a random ID number. Every student now will get a random ID number. It's not exactly random, and this is not great, but just for our exercise here, right? Now you will always have the same ID number because there is no public function to change it, right? It's essentially read only, and that's okay. That's a good thing to have because not everything of your classes should change, right? So you can only really do that if you change the value or take it in the constructor. That's all. All right, so we've got that. So we've got our functions here. So if I wanted to write a function then for printing student details, print details, I want a student pointer for student. Now, basically we do the same thing here. I don't want to do the set score, so now I can't use the dot notation, right? So I have to do the arrow notation. And we should do the ID as well here, right? So we can see out the ID. ID student dot get ID or arrow ID, right? And an end line. Oh my goodness, those are the wrong arrows. Wrong arrows. There we go. I can't type today. It's Monday. So if I want to pass a student pointer to my function here, what did I call that one? This was print details pointer. There we go. Print details with a pointer. So if I want to call print details with a pointer, I have to give it something that is a student pointer. So I have my students here, right? I have Eric, but Eric's not a pointer, right? It says you can't convert them. I could say, hey, here's the address of Eric. It's technically happy with that, which is kind of weird. But remember, a pointer's value is a memory address, right? The value a pointer stores is a memory address. So the address of Eric is the value of a pointer. Kind of silly, but it's okay. So we can print details with a pointer of Jeb. I can print details pointer with VB. Now, you can also, if you don't like the arrow notation, which is okay, I'll do it here. So you could dereference student here, and this is why I usually use the parentheses here. So we could say, hey, I want to dereference student dot get ID. So on this side then, if you want to dereference student, you get the value stored in memory. Now you can use your dot notation. I hate doing this because there's a lot more typing, right? That it's just the arrow works for me here. So this is the option though, right? You can dereference the value to use your dot notation, or you can just use the pointer and use their arrow notation. Oops, I should probably not have the memory leak. Let's go and I'll just put all this up above, right? Let's just do this up here. All right, and we'll do it. Maybe put a breakpoint there so it stops. I want to see the details, right? So we see Jeb's ID, no, so Eric's ID is garbage, Jeb's ID is garbage, Vivi's ID is fine because the other constructor never set ID, right? If I called the default constructor, ID never got a value. I got the garbage value. I only get an ID when I use the parameterized constructor, right? That's not very good here. So maybe it'd be nice then to call my own constructor, right? So I need this. Is it with name and score? No, is it this arrow? What is it here? Oh goodness. Uh, there's syntax for it here. I don't even remember right now. I'd have to go look it up. I don't remember what it is. That's all right. You can call another constructor from a constructor. Let's go Google it. Let's call constructor from constructor. See what we get here. Colon. There we go. Colon. Sure. So I'll say colon student given name and score. There we go. So this is really ugly here. I'm sorry. I'll just leave it out. Don't worry about it. You can get to it later. That just looks really confusing and ugly. All right. So we did pretty good on constructors, right? Later on, we can do other cool things. This idea of copy constructors, copy assignment operators, not too big of a deal right now. We'll come back to that later. Um, don't worry about your first linked list. You'll get it into linked lists in 200. They'll hurt your head for a little while here to kind of puzzle through it here. It's okay. But our string functions with pointers, right? This idea that we can have C strings. Remember, C strings are just character arrays with that null terminator. Remember, we looked at passing the null terminator or using the null terminator, and C strings just kept on reading till they found one because C strings are dumb. So the string class is so much easier in C++, right? Does that ring any bells? Okay, a little bit. So you can do all sorts of stuff with strings here. Substrings, string char, string reverse char, and string is one of my favorites here. You get a null pointer if string 2 does not exist in string 1. Else return a character pointer pointing to the first character of the first occurrence of string 2 within string 1. But you get back a pointer, right, of where is this thing in your string. Because remember, a string, the C strings are just like arrays. So it'll give you essentially the pointer value here. C strings or dynamic arrays are really annoying. You can do some weird stuff with them here. All right. So I haven't done anything super interesting yet. Like the idea that we have pointers is cool, right? Doesn't really give us new functionality yet. Yet we can put something in the heap. For our programs, we really don't care. We're not doing anything that large where we want to put stuff in the heap, allocate stuff in the heap, and then not have it on the stack. But eventually, you don't want your programs running all in the stack. You want to use the heap for storing stuff because it's a larger memory store. So that's the better place to keep stuff is in the heap. Um, Later on, we can do other cool things that only work with pointers and classes. So if you take a peek at the inheritance chapter, some of the cool stuff with inheritance only works when you use pointers, when you're using functions. That's just a sneak peek. You'll get to it next semester. Not too big of a deal. So I think we did pretty good here. Let's take a look and see. So we've got a couple things we were supposed to hit, right? Um, we didn't spend a whole lot of time on use case and activity diagrams. We talked about those little pictures we did a while back. The idea is that does my code go left or right? Right? Is it a yes, I do this. If it's a no, I do this, drawing a picture of it. Um, use cases are sort of putting pictures to how do I want my program to work. So we can spend some time on that on Wednesday. We did some really basic recursive procedures. That's the function that calls itself. We just did the really basic, like we'll count down. We said, hey, if it, if it's greater than 0, call countdown again with my number -1. That's about all that one did. Small programs in a modern programming language, C++ counts. Edit, compile, execute programs, right? Using like Visual Studio or whatever you're using. And then use Visio to draw our activity diagram. We can do that again when we come back for lab. So we've got today. So unfortunately, I can't stay for lab. I've got to take my daughter to the doctor. The clinic was only open Mondays. That's, of course, the way they do things. Um, but I'll have a lab for you so you can practice some basic pointer things, some play with it. Um, and then on 12.4, maybe we'll do the Visio stuff really quickly. Maybe we'll look at drawing a picture for Monopoly because that'd be kind of fun.
So, um, there will be a lab, but we don't have like a lab.
So I'll post a lab assignment if you want the room be open to work on it, but I won't be there.
Oh,
Yeah, so sorry, well, I can't stay today. We'll finish out point. I'll talk more about the UML stuff on Wednesday. We'll practice it real briefly, maybe use it to draw a picture of our final project. That's kind of a fun step. Hey, this is what my program should do. It should do this, it should do this, it should do this sort of thing. Those are use cases. What should my program do? Right? We can just Google it real quick. UML use case diagram. They got some good ones out here. Some of these are really pretty, and some of them are not. It's really small. Can I make it larger? View image. There we go. So the restaurant use case has these are the different people that play a role here. These are the different things that happen, right? It's sort of a way of making a picture of what the system does here. So what does our system do? Well, it needs to deal with orders, right? We need to have a way to serve things. And wine is different depending on whether or not your waiter is 18 and older or 21 and older, right? We have different rules about that thanks to our laws. Sure. Uh, the client or the person at the restaurant, right? They want to order, they want to eat and do their things, and then the cashier, right, has them pay for things. So the system is interacted by all these different actors, we call them, because why not put fancy names to things? And we look at what role do they play in the system? How do they interact with it? So restaurant's a little bit silly here, but they've got some other fun ones. I think what was the other good one? It's another restaurant one. My goodness. I can't click on these things. Online shopping system. No, that's not what I wanted. I can't. Right. So your customers, right? Things that they want to do with your online shopping system. Hey, it's Cyber Monday, right? If you haven't spent enough money by now, spend more money, please. Right. Um, you view items, you purchase items, you check out items. You have to register. So once you're registered, you do different things. If you haven't registered, right? You can view things, but you can't check out. You have to register first. And then who do we work with, right? On the other side, these are actors. They're not necessarily people though. Like PayPal is just we get money from them, right? So they're an actor as part of the checkout process. That's all. So it helps us think about the way systems interact when we draw a diagram here, which is kind of fun. So we'll spend a little more time looking at those. It's great to have a picture, right? They really are worth 1,000 words, so we can think about what we're doing before we go and do it. And that way, everyone who's working on a larger system knows what's happening here. We're not all just go running off in 1,000 different places here. So if you have a team of people, you know what's supposed to happen at the end here. You know the goal with a little bit better detail. So pictures are great. So we'll spend a little bit of time with that. Other than that, I think we're about done. And that is about all the content then. Um, yeah. So make sure you get started on the final project if you haven't yet. Right? Build little piece by little piece by little piece. Right? If you want all properties to be the exact same property to start, that's perfectly fine. Right? Have a bunch of Baltic avenues or Mediterranean avenues. That's okay. Right? Later we can go change their values. That's okay. Right? You don't have to have it all done right at the start. Right? Or if you want to make them all just blank properties, they're all free space. That's a fine start. And then maybe we'll go add just one property or go add two properties, or then maybe we'll make passing go work, right? Any way you want to start adding in these features, just start building them out little bits at a time here. Make your commits, right? It's good for you because then the cloud has your code, right? There is no my computer broke because the cloud has your code, right? You want that. That's good for your code. Um, and then it's good habit to get into, right? Building out small things, not waiting for the last day. It's good for you too. Um, and then it makes it much harder for you to cheat and ask the chatbot to build you a Monopoly game if you can only copy paste in code that runs, right? And honestly, that's one of my goals here is that people don't just go and ask chatbot to solve their homework for them, right? So we want to try and build, so use it. If you get stuck something, ask for help. That's perfectly fine, right? Cite your source, right? Tell me what prompt you used. But again, 50% or less can be cited, right? You've got to have original work, just like an English paper, right? You're not turning in 75% quotes, right? Your English paper, your English teacher will throw it back at you. Pretty sure. I should ask them. That's the way it used to be, at least, right? Okay. So I'll post the lab assignment. Sorry, I won't be there for it though. Take your time on it. If you want to show up and work on it, great. If you want to work on it throughout the week, that's cool too. We'll come back on Wednesday, wrap up our last couple topics. We'll have some more work time for the project. A couple people have told me they're working with partners. I should have set up your shared repositories. If you're waiting to hear from me, just ping me again. I might have lost it. My little guy got my phone, and now it's beautiful here. Like I'm missing half the screen on it now, so which is really sad. Um, but we'll uh, we'll get a new one eventually. So, all right. If you got any questions, let me know. If not, I'll see you folks on Wednesday.